The way it's typically been done in /package packages, and something that I really like about this system, is you typically have just one file per configuration parameter. So how to invoke the C compiler, how to invoke the linker, where are my dependencies, where am I if you're installing the package in some non-standard location, which typically you should avoid that, but if you're not root, you can't really help it. So these things, each one is represented in its own file. The benefit of that, as opposed to having a bunch of variables in a makefile or whatever, is that it's very easy for programs to read and to write that information. You want to know where this one dependency is, you just slurp in this one file and that's where it is. Or actually the way I do it is the first line of the file is the value of that parameter and the rest is a description. So that's a nice way to make it self-documenting as well. Runtime configuration is pretty much similar in my packages, at least. Anything that applies to the whole package has to go in the package directory. Whereas if you're running a web server, for example, you could be running multiple instances of that, and so that configuration data doesn't really belong in the package directory because there could be more than one of them and they can't all have the same name. But anything that does apply to the whole package would go in there, and the way I do it, it's pretty similar, one file per parameter, and so far the only kind of configuration like that that I've needed is where do I find my dependencies at runtime. And the way I do that is I've got a dependency compile time configuration file where when you're installing the package you can say if one of your dependencies is in a non-standard place, you can say it there, and then the build system will create a symlink to that and put that in the runtime configuration directory. Then I always find the dependency by way of that symlink, which is in my own package directory, so if it ever needs to change, that can be changed independently of anything else on the system. So for example, you've got package foo and it's needed by packages bar and baz. Well, maybe bar needs version 1.2, but baz needs version 1.3. So you can have foo 1.2 and foo 1.3 installed at the same time, and bar and baz can both use the versions they need and those don't conflict. The way you see this handled typically right now without /package is version numbers are embedded into library file names and all sorts of things. I think that's kind of messy. So now we've taken all this work away from the distro. Is it still meaningful to have a distro? What's left for a distro to do? Well, distros do a lot of QA work, and that's certainly valuable. The question then becomes, how would a distro play nice with /package? And if a distribution wants to say, okay, we've tested this combination of package versions, they work very well, you can rely on them pretty much. What they could do is they can use the package host automatic delegations, and they can set up this symlink here as an alias of another package. So package host vendor.com admin foo is just a symlink to a specific version, the version they've tested of package admin foo. And then if the admin decides I want to try out version foo 1.3 and use it for most of my own things, I can install foo 1.3 and I can update the package admin foo current version symlink, but the vendor's symlink still points to foo 1.2, and anything of the vendor's code can still find foo by way of their own vendor symlink, and so everything works. You can still, if you like, wrap all these files in your old package format if you want that kind of normalization. that won't break anything. The main thing is that once the files are on the system, you can find them by their standard paths. That's where the portability benefits really come from. Shared libraries. Basically, it is possible to do these without having one global search path that includes every package's library directory. There's a couple of different ways to do it. You can either I have my own search path for my package that looks in just these library directories for my dependencies, or you can put absolute paths in the SO name so that I link directly to the file I'm looking for without any searching needed. That at least works for ELF-based shared library systems. Not so sure about others. I don't really know. /package is about 4 years old now. Little more. The earliest reference, I have a terrible memory for time, but the earliest reference I could find for it was archive.org had the webpage at February 2001. I subscribed to the mailing list in January, but there wasn't any traffic till February. And in that time, it has undergone some evolution. There is still room for more improvement. One thing that I'd like to see is the URL for a package tarball could be included in the registry. So that way, a higher level tool can say, I want to install package admin foo. Okay, go look at the registry, see where that tarball is, automatically download it. No human intervention needed. I kind of suspect that's not going to happen, so I just might set up that sort of thing independently of the registry. And that would still work just as well. Configuration, I mentioned the way I do things. Other packages tend to do things pretty similarly. We're all kind of cut from the same cloth so far. The adopters of /package have usually a common aesthetic taste up to this point, but everything is not quite the same, and so it would be nice if we had some kind of spec for how that should work, and that would make things easier on the users. There could be room in the spec for more things like, once you've built this package, can you delete the source directory? In many cases, yes. In a few cases, there are packages that still need to refer to things in their source directory at runtime. If you've got something like a spool type directory for a mail manager or anything like that, it would be nice to somehow declare that this directory needs to be writable at runtime, and then a higher level tool can take the parts that need to be writable and the parts that don't and move them off to appropriate file systems, and then of course leave symlinks behind so that the standard access paths still work, but everything can be physically stored the way the admin wants it. Some of these higher level tools I've been talking about, I've written some, and since the package format is so simple and straightforward, these are pretty much just simple shell scripts. I've got one, sp install, that you give it the name of a tarball that's on that you've downloaded, or you can give it the path to a package in some cases, and it'll install that package. Some of the installation code, the setting the current version symlink, the command symlinks, that is really going to be the same for any package, and so that's included in sp install just in case there are bugs in that part of the code in any given package, which there are in some cases. In the case of upgrades, sp install can actually automatically locate and download the new version if the old version that you already have installed includes the appropriate metadata. For first-time installs, that's when you need the URL to be included in the registry or at some central location, and that is not there yet. but I'd like it to be. SP install can also do some automatic configuration. If you're installing things in your home directory, you can say, install this in my home directory and also look for dependencies there in case they're not in the root/package directory. Then I've got a couple other things here. SP check and SP globals kind of look over the system to see what you've got installed, look for anything unusual. As an example here, we can see what SP check finds. Here in the under package misc SPF, which I'll get to in a minute, it's finding lots of things because I'm pretty sloppy on my system, the way I admin it in some ways. So you've got all these multiple versions, that's not a problem, of course, but it is somewhat odd, and so it's reported here, and various other things like that can be reported. Oops. Yeah. Okay, so now SPF, which let the irony and hypocrisy ensue. SPF, of course, is on the one hand a name of a borked anti-forgery mail system, but when I'm talking about SPF, I'm usually talking about my /package foreign project, which takes packages that are already out there and installs them in a /package-like way. Now, the hypocrisy of this, if you want to call it that, is that I'm changing program paths. I'm making the old path not work anymore. This is exactly what /package was supposed to prevent. Dan Bernstein, who created /package, doesn't really like this idea, but I see it as a trade-off, and it's a trade-off I like. I am giving up some of the portability benefits there. I'm making more work for myself when I want to install a dependent package. I have to tell it where to find everything it needs. But the atomic, reversible, non-destructive upgrades, that's something I really like, and that is a benefit I get out of this. And so here we see some of the paths that you might end up with in this system. This is actually not the way things are done right now. These are not the paths you saw a second ago. But this is the way I'm in the middle of rewriting a lot of the system, and this is what it's going to look like in the future. Real soon now. And if you ask me again a few months ago, I'll tell you the same thing. Yeah.
The changes that you make in your build scripts that you build outside packages to your hierarchy, are those things you can submit back to the individual software maintainers that you can accept or not?
In some cases, there are things that I like to submit upstream. This is usually adding the flexibility to install things this way. I would not, of course, submit upstream to make this the default, because that's a much bigger change. But, like, for example, a lot of things will do a test for the exact file, user include whatever. And so I may submit a change upstream that says, instead of testing for that file, try to compile a test C file that includes that file, and let the compiler figure out where that file actually is. That's a pretty common one. So the way this path scheme would work in the not yet existent SPF system is every package can be repackaged by pretty much anyone, and they can distribute their own repackaging under package host and their domain. So, for example, I have the domain dogmap.org. I put all my code on code.dogmap.org, and so I can install the package host code.dogmap.org/foreign/bash 3.0. And that can be my take on how to install bash under /package. And within that directory, it'll look pretty much like any other /package package. I can install GCC 343. I can install glibc 235 under slash package, it doesn't have